Hello class, this is the third example on the sum and product of roots of cubics. So let's go straight into this example. So we want to solve for this example, where we're being told that two of the roots are equal. So let's first address this limitation, or this piece of detail. It's saying that if we have alpha, beta, and gamma, we can let any two of them equal one another. So in this case, actually, let's make it a little bit easier. I don't like drawing gamma, so I'm going to let gamma equal beta. So now when we do the sum of these roots, alpha plus beta, now instead of gamma, since gamma is equal to beta, it's now equal to alpha plus beta, and that's going to equal negative b on a. In this case, b is 32, so negative 32 on 12. Let's simplify that. 32 on 12 is going to be negative 8 on 3. This is also going to be alpha plus 2 beta is equal to negative 8 on 3. So we've used this one. Let's now use this one, because why not? We'll just go across and let's see what we can come up with. In this next sum and product, alpha, beta, plus, now take a look. Instead of alpha, gamma, remember that in this particular example, gamma is equal to beta. So instead of alpha, gamma, it's going to be alpha, beta again. Likewise with this, beta, gamma. Gamma is now beta. That's going to be beta times beta. Beta squared is equal to c on a. C is 15 and a is 12. We can simplify the left-hand side. That's going to be beta squared plus 2 alpha beta. And this can be simplified into dividing both by 3. It's going to be 5 on 4. So now from here, it seems as if we can actually solve for alpha and beta in this case. Now, from having alpha and beta, we could find the solutions for x and y here. So let's keep going. Let's make alpha the subject here. So alpha is equal to negative 8 on 3 minus 2 beta. We're going to substitute this into our next expression of 2. So we're doing a nonlinear simultaneous equation. So beta plus 2 beta times, I'm going to substitute for a here. So, not a, alpha. It's going to be negative 8 on 3 minus 2 beta is equal to 5 on 4. Expanding this, we get, that's beta squared. Beta squared plus, expanding this, we get, it's going to be negative 16 beta on 3, that's 2 times 8, and 2 times 2 is going to be negative 4 beta squared is equal to 5 over 4. Collecting like terms, beta squared minus 4 beta squared is negative 3 beta squared minus 16 beta on 3 equals 5 over 4. This looks a bit like a quadratic, so let's get rid of these values. So we'll multiply everything by 3, gives us negative 9 beta squared minus 16 beta equals 15 on 4. Multiplying everything by 4 to get rid of this one here, negative 36 beta squared minus, that's 40 plus 24 minus 84 beta equals 15. I'm going to move everything from this side to the right hand side to make it positive. So it's going to be 0 is equal to 15. 15 plus 84 beta plus 36 beta squared, which I can just rearrange to make it look like the following. Just going to rearrange it to make it a little bit easier to work with from left to right. And there we have it. Now this is just a quadratic equation. You can solve it however way you like. I'm just going to use the quadratic formula. Beta is equal to negative 84 plus minus, oh wait, sorry, I just realized 4 times 4, that's 64, not 84, 64. So negative 64, my apologies. Negative 64, that's going to be b squared minus 4ac. I'm just going to substitute my values for a, b, and c. It's going to be b squared minus 4 times 36 times 15. Underneath this is going to be 1936 over 2 times 36 is 72. Evaluating this a little bit more, beta is equal to negative 64 plus minus square root 1936 44 all over 72. Okay, so we're nearly there. We nearly have solutions for alpha and beta. So let's grab this. And we'll grab the two solutions, one for the plus, negative 64 plus 44 on 72. And the other one's going to be negative 64 minus 44 on 72. Inputting these both in our calculator, negative 64 plus 44 on 72, negative 5 on 18. This one's going to be negative 64 minus 44 on 72. This is negative 3 over 2. Once we have these two values, we can solve it using this original expression here. So let's grab that one again. And let's find the values for alpha in this one. So substituting here, let's go straight into our calculator. Alpha is equal to negative 8 on 3 minus 2 times negative 5 on 18. In case you're wondering what I'm typing in, it should look like this. I'm just substituting this value for b. So equals, we get negative 19 on 9. And for this one, when we substitute negative 3 on 2, negative 3 on 2, we get alpha is equal to 1/3. Now remember, the roots themselves, these answers will, well, when they're substituted, should give us 0, because that's what roots are equal to. But we actually have two pairs of possible solutions. We have alpha equals negative 19 on 9, and beta equals negative 5 on 18. So we substituted these two, so those two are the two solutions. Or it could possibly be this other pair. Alpha is equal to 1/3, and beta is equal to negative 3 on 2. So which two could possibly be the correct pair? Now what we can do now is we should now use the third identity for the sum and products to check which ones are actually correct. Because if we were to substitute these back into the original equations to check if they work, these would all work, but I'll demonstrate to you what I mean from here. Let's now just take the identity here, alpha, beta, gamma, but remember, gamma is now beta. So it's going to be alpha, beta, gamma will now be alpha, beta squared is equal to negative d on a. So negative 9 on 12. Okay, so 9 on 12. We're going to be using this third identity to check if these pairs actually give me a result. Here's what I mean. I'm going to substitute this into alpha times negative 5 on 18 squared. And this should give me, I believe that's going to be 3 over 4 when simplified. So when we multiply this out, it should give me, if you take a look, it's not giving me 3 over 4. So this, when we make it as a fraction, this is negative 4752916 does not equal 3 over 4. So this first pair, that is not the solutions. Whereas if we were to substitute the other values, so let's try the other pair here. Let's substitute both of these here. Let's take a look at what happens. We get 1/3 times negative 3 over 2 squared. This gives us 3 over 4. Notice how this pair, when substituted into the third or the product of all three roots, it actually equals the values given. So the correct solutions for this, let's go back here, are x is equal to 1/3, and the other solutions are negative 3 over 2. So these are the two solutions for x that will give me 0 when substituted here. So I hope that gave you an insight into the sum and product of roots. Hope to see you in the next video. Best of luck.